Hello, and welcome to the presentation of our paper Mixed Signals, Sign Language Production via a Mixture of Motion Primitives, presented at ICCV 2021. My name is Ben Saunders, and I conducted this work alongside Najati Jihan Jamgus and Richard Bowden at the University of Surrey. Sign languages are visual languages used by the deaf communities. Analogous to phonemes in spoken language, continuous signing can be broken down into sequences of cheremes, represented as motion primitives, a set of motions that are combined to represent all sign language utterances. Sign language production is the automatic translation from spoken language sentences to continuous sign language sequences. Effective production requires both an accurate translation from spoken language into sign language grammar and a subsequent expressive animation of the sign language sequence. Previous SLP work has traditionally employed a single model to tackle both the translation and animation tasks. This strategy results in an expertise in neither task, leading to a poor translation and an underexpressive sign language production. In this work, we propose to formulate SLP as two distinct but jointly trained subtasks. We initially translate from spoken language to a sign language representation with an additional gloss supervision. Subsequently, we propose a novel mixture of motion primitives architecture to animate skeleton pose from this sign representation. This setup leads to both a more accurate and more expressive sign language production. Our full model architecture is split into two networks. Firstly, we use a progressive transformer network to perform the initial translation to sign. We add gloss supervision as an intermediary translation loss, using a CTC layer to collapse the frame-based sign representation to a gloss sequence. This prompts the model to learn a meaningful latent representation for the ultimate aim of sign language production. Our subsequent animation network is then tasked with transforming this sign representation into expressive skeleton pose. We build a novel mixture of motion primitives network that combines learnt motion primitives using a mixture of experts model. We build our motion primitives as transformer encoders, each locally specialized for specific sign motions that are temporally blended to produce sequences of uninterrupted, continuous signing. We use a gating network to learn the blending of expert outputs per frame and employ a skeleton pose difference as our animation loss. We train our full model end-to-end to produce skeleton pose sequences using a weighted combination of our translation and animation losses. We evaluate our model on the Phoenix 14T dataset using the state-of-the-art SLP evaluation metric of back translation. We first evaluate our model on the gloss to pose task, achieving state-of-the-art performance that highlights the effectiveness of our proposed mixture of motion primitives network. Moving to the text to pose task, we first ablate our proposed translation and animation losses and show that adding gloss supervision significantly improves performance. We also achieve state-of-the-art performance on this task, achieving an 11% increase upon baseline methods. We believe this is due to a combination of both our mixture of motion primitives architecture and our translation and animation decoupling. Surprisingly, our model achieves higher performance on the text-to-pose task than the apparently easier gloss-to-pose task. We believe this is due to the wider context available in spoken language compared to sign glosses, with our gloss supervision prompting a meaningful, learnt sign language representation. In addition, we perform a perceptual study that shows our output has better lifelike motion than the baseline for both the overall skeleton and specifically the hands. Qualitatively, it can be seen that our model produces varied expert allocation for different sections of a continuous sign language sequence, utilizing the full motion of mixture of motion primitives architecture. To conclude, the contribution of our paper are as follows. A novel transformer-based mixture of experts architecture that combines learnt motion primitives at the frame level. The first SLP network to separately model the subtasks of translation and animation. And finally, state-of-the-art SLP performance, with a translation performance better from spoken language to sign than from a gloss intermediary. Thank you for listening to our presentation.